Welcome to the video on building your home lab. So the virtual home lab is one of the most important tools you can use to prepare for the CompTIA CySA Plus certification, and it's important to understand why. The CySA Plus is a performance-based exam, meaning it tests not only your theoretical knowledge, but also your ability to apply that knowledge in real-world situations. A home lab provides the perfect environment to gain that hands-on experience. It allows you to configure SIM tools, IPS, IDS systems, firewalls, and endpoint monitoring solutions. You can analyze logs from Windows and Linux and network devices. You can simulate attacks, you can perform incident response, and even test vulnerability scanning, patching, and remediation workflows. Without this hands-on practice, it's extremely difficult to fully grasp how these tools and processes work just by reading or watching the videos. The home lab also gives you a safe environment for experimentation. Basically, you can break things, misconfigure services, and simulate attacks without the risk of harming real systems. This freedom to explore how tools behave under different conditions allows for trial and error learning, which is invaluable for developing both confidence and competence. You can repeat exercises as many times as you need until you understand them completely. Another major benefit is that it helps reinforce theoretical concepts. The CySA Plus exam covers several domains, including security operations, vulnerability management, incident response and management, and reporting and communication. By setting up virtual machines, configuring networks, and working through real-world labs, you strengthen what you've studied in books or online courses, or even the theory lectures in this course, and it will help the material stick more effectively through active learning. The lab also enhances your troubleshooting and problem-solving skills, which are essential in any cybersecurity role. In real-world environments, you'll often need to configure or figure out why the SIM isn't ingesting logs, or why a snort rule didn't trigger, or why a vulnerability scan missed certain hosts. Building and maintaining your own lab forces you to troubleshoot issues like these, and it trains you to think critically and to solve problems. And these are skills that are tested both on the exam and in actual security operations. Beyond technical skills, a home lab can boost your resume and career readiness. Practical lab experience gives you confidence during interviews and provides concrete examples of hands-on work to discuss with employers. It also shows initiative and self-motivation, qualities that are highly valued in the cybersecurity industry. Having a home lab can give you a strong edge when pursuing entry-level positions such as SOC analyst or cybersecurity analyst. One of the best parts about the lab is that it's low cost and is highly scalable. With virtualization tools like VirtualBox, VMware, Workstation, Proxmox, or Hyper-V, you can build a powerful and versatile lab on a single laptop or desktop. You can run multiple virtual machines, such as Windows, Linux, pfSense, Metasploitable, or Kali Linux, and easily expand or reconfigure your environment as your skills develop. This flexibility makes it an affordable way to get enterprise-level experience without expensive equipment. In summary, a virtual home lab transforms your CySA Plus preparation from passive learning into active skill building. It provides the hands-on experience, troubleshooting ability, and real-world exposure that not only helps you pass the CySA Plus exam, but also to prepare you to excel in a professional cybersecurity role. To complete the hands-on labs in this course, students must have access to a computer capable of running a virtualized cybersecurity environment, a modern 64-bit system with at least 16 gigabytes of RAM, a quad-core processor, and about 200 gigabytes of available disk space is recommended. All instructions in this course will be using VirtualBox, which is free and cross-platform, but students may use any hypervisor of your choice. To make the process as efficient as possible, We'll build a simple lab environment using only 2 virtual machines, one Ubuntu server with Docker installed and one Windows 11 VM. By leveraging containerization, we can run services like Splunk and OpenVAS directly in Docker containers instead of deploying additional VMs. This setup reduces complexity and maximizes your time for hands-on practice. For those who wish to expand their environment later, optional lessons at the end of the course will walk you through building a complete enterprise-style lab that will include firewall, DHCP, DNS services, multiple LANs, and an Active Directory domain. However, in the labs throughout this course, we'll use this simplified lab environment depicted on the screen. What we'll do now is build the Ubuntu server, and we will install the Docker engine and the Splunk container, and then we'll take a snapshot of it, and that's as far as we'll go in setting up the Ubuntu server. And then as we go through each lab lesson, we will include additional services if required. Obviously, the first thing you need to do is download the ISO for an Ubuntu server. Make sure that you choose server, and you could get that from ubuntu.com. There is a link to the download page in the walkthrough. So once you have it downloaded, now you're ready to start building the virtual machine. Okay, so now you've downloaded the ISO. Now you can create the virtual machine, and hopefully this is not the first time you've done this. So to do that, you have several options. You could just go to the group menu and select new machine. You could also just right click on a group. So I have a CySA Plus group created. I'm just going to right click and add new machine. And you're going to get this menu either way, however you get to adding the new machine. And then you want to name it. So I'm just going to name this CySA Plus server. And this next folder, that is where you want to store your virtual machine once it is created. And then you have the ISO image. So this ISO image is where you'll navigate. You will navigate to where you downloaded it. So I put it in this folder. It could just be in your downloads folder. And then the rest should auto-populate. The type is Linux, subtype Ubuntu, and then the version Ubuntu 64. Now you do want to select skip unintended installation and then go down to the hardware dropdown. Now this is where you'll give the resources to your virtual machine. I'm going to give this 8 gigabytes of RAM. So if you have 16 gigabytes of RAM, then you may want to give this one 8. If you have more than that, really 8 gigabytes is all you need. If you only have 8 gigabytes of RAM on your machine, then don't give a virtual machine any more than half of the resources on your host machine. And for processors, I'm going to bump it up to 4. I have a large amount of processors, so it's not going to be an issue for me. However, once again, if you only have a quad-core processor, then only give it either 2-core or 1. And then lastly, we do not need to enable EFI, and we'll hit the drop down for hard disk. I'm going to bump this up to 200, and the reason being is we're going to install Docker on this and several services. I just want to make sure we have enough space. Now, if you don't have that much free space on your host system, you do need to give it at least 60 gigabytes because when you install Splunk, it requires some free space. Now, the good thing about giving it like 200 gigabytes is unless if you select pre-allocate full size, it's not going to eat up 200 gigabytes on your host system. It is only going to use what it needs up to 200 gigabytes. Unless if you select pre-allocate full size, so do not select pre-allocate full size. So if the virtual machine is only 10 gigabytes, that's all it's going to use, even though I'm allocating 200 gigabytes. We'll leave the use existing virtual hard disk file and the do not add a virtual hard disk blank. So basically the only thing we're doing under hard disk is adjusting the size of the hard disk, and then we will select finish. Okay, so we're not really done yet. We see our CySA Plus server. We want to go to settings at the top on the VirtualBox Manager. A couple changes that we want to make on this. First, we'll go to System. We can deselect floppy, and let's go ahead and move hard disk to the top and then optical below that. Now we will probably be required to deselect optical once Ubuntu is installed. The optical is only used because that's the installation device that we're using when we install Ubuntu. That's what that ISO is. So from there, we're going to come down to network. And what we're going to do under network is we're going to change the network adapter to bridged mode. So what bridged mode does is it will get its IP address from your home router. And the reason we want to do this is we will access this virtual machine from your host machine, from a browser on your host machine, for most of the web-based stuff like Splunk and OpenVAS. And this allows us to get by with running less virtual machines. And also by putting in bridge mode, it ensures it will be on the same network segment as your host. And when we create our Windows virtual machine, we will also put that into bridge mode. So once again, it's getting an IP address from your home router, so it will be in that same IP range. Now, this is not the setup you'll do in some other lab setups, but for this one, this will work best. Once you've done that, you can go ahead and select OK. And you're ready to start the virtual machine. So just select Start. And at this point, just select Enter. And if these are in your way, you can go ahead and X out of those. Now, as you install the server, it's going to change window size. Don't worry about the window size right now. In fact, once we get the server up and running, we're really not going to interface directly with the virtual machine console. We are going to SSH into it. So at this point, you select English for your language or whichever language you prefer. And the same for the keyboard. So you can you see at the bottom is done. You can just select Enter. We can go with minimize server. So to do that, down from here, we can select the down arrow and the space bar. So once again, the down arrow takes it down and the space bar puts the X in it. And then you can go down to done. And the reason we're doing minimize is the only thing we want to run on this server right now to be installed on it is SSH. And then from there, we will install the Docker engine. So we'll go ahead and tab down to done, select done. And now you see, because we're in bridge mode, and we're using DHCP, it is getting its IP address from my home router in this case, and this is the network range that my home router uses. So once you've done that, we can go ahead and select done. And under proxy address, we're just going to leave that blank. And at this point, it's checking the mirror address. So this is where it's going to download the required packages. And once it says this mirror location passed test, then you can go ahead and select done just by selecting enter. We do want to use the entire disk, and this is the entire disk that we allocated it, not the full 200, but as I explained before, it will use as much disk space as required up to the 200. So we can go ahead and hit tab down to done. We're not making any changes. And this is just an overview. Everything seems to be in order, so we're going to go ahead and select done. And it's giving you one more chance, because this is basically if you were using this ISO to install the operating system on bare metal, or on your hard drive. It's giving you a chance to not overwrite everything that you have on your disk. But since we're doing it virtually, it's not a problem, so we just select continue. And here we are with name. So you can type in whatever you want to here. For uniformity, I'm going just to use the name student. For the server name, I'm going to call it CySA Plus. It has to be all lowercase and no special characters. I'm just calling it CySA Server. And then we pick a username. Let's stick with student. And choose a password. For everything during this course, I'm using password 1 with a capital P and then the number 1 at the end. That is just to keep it simple. Obviously, you would not use a password like that in the production environment. But when you're working with multiple virtual machines in a lab, you need to use some kind of a nomenclature that you can easily remember. Okay, at this point, we do not want to enable Ubuntu Pro, so we'll keep skip for now selected, and we'll hit enter on the continue. Now, this is what we do want to install, is the Open SSH server. So just hit the space bar, and that will put the X there. And that's the only change that we want to make. And then tab down to done. And once you're there, hit enter. And we're not going to install any of these. So we're going to tab down to done and hit enter. And now it's going to install. And I'm going to go ahead and pause during the install. The install is complete, so we want to go tab down to reboot now. We'll select reboot now. And this is the error we expected because it's failing to unmount the CD-ROM. So what we'll do now in VirtualBox Manager is go to settings, go to system, and now we want to deselect the optical, select OK. And now if we go back to our virtual machine, hit enter, and now it's starting to reboot. All right, so now we're done. It's that simple. So to log in, just remember the login name. I use student and the password. So now we are logged into the Ubuntu server as student. Now, remember I said what we wanted to use this server for is pretty much like a headless device, so we're not going to interact directly with the console very much. So we want to SSH into it. So the only thing we need to do right now once we get logged in is to get the IP address. So if we type IPA, we see the IP address is 192.168.0.145. That is in my home network range. So now what I want to do on my host system, I'm going to use PuTTY to SSH into the server. And the reason I'm using PuTTY is I'm on a Windows system. PuTTY is a Windows application, so it's really easy to copy and paste into it, and we don't have to mess with trying to install the guest additions on the actual server. and it keeps the server more lightweight. There's less interference with it. And as I said before, a lot of the services that we're going to be running on the server are like web-based, so we'll just be logging into them from our browser on our host. But to use PuTTY, if you haven't used it before, you can Google it and download it. It's pretty lightweight, and then you just type in the IP address of your server that you're SSHing into, and just keep everything else the same. It is SSH, it is port 22, and then select open. And the first time that you run it, you will be asked, you will get this security alert, and just go ahead and select accept. And now I'll move this to the center of the screen. But what it's doing now is asking us to log in. So once again, the username is student. And the password is password 1. And it may take a few seconds to get logged in the first time. Now we're logged in. You can see we're on the CySA server. And if you just wanted to be sure of it, you could type IPA, and it gives you that IP address, the 0.145. And you could even type who am I, and that lets you know that you are logged in as student. So then we could just minimize the virtual machine console, and we'll do all of our configuration from this SSH window. So I'm just going to increase the size of this window so we can see it a little better. And I'm going to type clear just to clear the screen. We can see what we're doing. So the way the walkthrough is set up is basically all the commands that we need to run to set this up is in the walkthrough. So the first commands that we need to run is we want to go ahead and install some additional items onto the Ubuntu server that we need to use during our labs. So that includes curl, wget, nano, nettools, and some other things. So in the walkthrough, you see those commands, and you can just copy those and then run them. So like in this case, as I paste them into the window, you see it's actually two separate commands. We're going to do the apt update and upgrade first, and you should always do that when you're installing packages, and then also the install. So once we have those pasted in, we can just select enter, and we are prompted for the password because we're using sudo. And now with the installation should begin. Okay, so while this is installing, I'll go ahead and pause the recording. Okay, that is complete. And to check, one way we can check to make sure that the things were installed is we can run ifconfig. So ifconfig is not automatically installed anymore on Linux. So that is part of those nettools. And if I run ifconfig, you see we get the interface information, including our IP address. So that lets me know that we were successful in installing those applications. Now what we want to do is install the Docker engine. So same thing as before, in the walkthrough, you can just copy those commands and paste it into the terminal. First, I'm going to clear the screen so we can see what we're doing, and then I'm pasting it in. So you'll notice what I've done on the walkthrough is I've commented things out just so it makes it easier to understand what each command is doing. So for instance, the add Docker repo and key, and then it has the sudo install, and it's going out to grab everything we need. And we also see that we're using curl. That's why we had to install that earlier. Now, I'm not going to go into a whole lot of detail about Docker and how it works. We will have a lesson on containerization later in the course, but at this point, we just want to get this lab set up so that you'll be able to jump right into the course. So we can go ahead and select enter. And we're starting to install the Docker engine. All right, that is complete. Didn't take a whole lot of time. So there's two commands we can use to check it. I'm going to run them at the same time. So the first one is Docker version. That will just tell you what version of Docker that we've just installed. And the second one is this Docker container called Hello World. And that is just a test to make sure that Docker is working. So the way this will work, I'll hit enter. Right away, we see the version. And now you'll see this. Every time you install a Docker image, it says unable to find the image Hello World. In that case, nothing to be concerned about because that just means it's going to download it. So it pulls it, which is the same as downloading from the library. And if you see this hello from Docker, that means that it's successfully installed. So that we just pulled that image called Hello World, which is just testing that the Docker engine is working, and we're able to install an image. So now what we want to do is to create a couple persistent volumes. And the reason we want to install persistent volumes is a lot of the containers and images in Docker will run, and then once you tear it down or you stop it or the system restarts, there's nothing left. It's not persistent. So since we are using an image like Splunk, we don't want to lose everything every time that the system gets shut down or rebooted. So we just ran the command, and you could tell it is successful if you get the Splunk-etc or etc and then Splunk-bar. Another way that you can check to make sure that this was successful is just run sudo docker volume ls. And you see I had a typo on volume. This is why I like to copy and paste. So once we run the correct command, and every time you use sudo, you should use, or every time you use Docker, you should use sudo. And now we have what we're looking for. Those two volumes were successfully created. So what we want to do now is actually install the Splunk image. So there's really some benefits to using Docker for Splunk, especially the way we're creating it here. So I'll talk a little bit about this. So I've got it commented out, but we're creating both the license flags and a password for Splunk. Now it says strong password. It's not really that strong. However, what we're doing is sudo docker run is going out and it's grabbing that Splunk image, and the -p, that is for port. And what this does is maps ports on the machine on our Ubuntu server to that Docker container. So in this case, it's really simple. It's 1-for-1. So it's port 8000 coming into the machine is going to go to port 8000 on the Docker container. And port 8089, same thing. The reason you have this on there is if we had other services running on that server that use port 8000, we would have to map it differently because port 8000 would already be being used by another application, and we would have to choose another port, like say 7000. So when that came in, port 7000 on the server, it would go to port 8000 on our container, and because that's what the default ports are for Splunk. A couple other things that we're doing is we are accepting that license. And then here's two key things. You want to make sure that you are accepting the general terms, and then you're also setting the password. Now, if you've used Splunk before or set up Splunk before in a lab environment, you know sometimes it can be a real pain because you have to create a Splunk account. And to create that Splunk account, you have to use an email address that is not a general email address like Google or Yahoo. It has to be like a work or a school email address. So if you don't have one of those addresses, it can be a real pain. However, but when we set up the Splunk using Docker, you don't need that. It's going to automatically install. Now, it's going to be good for 60 days. And then after 60 days, you're either going to have to rebuild it again, or then you will have to create a Splunk account and change that license. So once we've done that, we can go ahead and hit enter. And there we go again, where it says unable to find the image Splunk. At first, you're a little bit scared. Don't worry about it. That just means it's going to pull that image or download the image, and you see the download starting. I'm going to go ahead and pause the video as it continues to install and download. Okay, so it's finished installing, and we can check to make sure it was successful by running the command that's in the walkthrough sudo docker ps. And that shows that it is starting right now. So it was installed correctly, and now the service is starting. And basically what we're looking for is the health status. Now, it does take a minute or two for Splunk to start, so you may have to run that command more than once. Once again, it's sudo docker ps. And it's still starting at 42 seconds. Like I said, normally 1 or 2 minutes, but you want to make sure that you get the status healthy, which means that Splunk is running. And this is what we have here, healthy. So once again, up about a minute. So it takes a minute or so for Splunk to start. We have the healthy status. So the next thing we want to do is to make sure that every time this virtual machine starts, that both Splunk and Docker will start. If not, you would have to manually start those services every time the virtual machine was turned on. So the first command will set so that Splunk will start every time Docker is up. And the second command is making it basically enabling Docker so that it will start every time that the virtual machine starts. And once again, that's important, especially for a service like Splunk, because of if the system goes down, you don't want to have to reinstall because you won't have the persistence, especially when you're forwarding logs and stuff. So now we have it set up so that both Docker and Splunk will start every time the system restarts. And we can test that by running sudo reboot. And it's rebooting now. Now, obviously, because we're SSH'd into it using PuTTY, we just got booted out of our SSH session because obviously if the system shuts down, we cannot be connected to it. So we're going to close PuTTY. If I open the terminal back up on the VirtualBox terminal, we see the server restarting. Now, it does not take long. See, it's already restarted. And what I can do now is log into it. I don't really need to, but I'm going to go ahead and log into it just to confirm the IP address. It is 192.168.0.145. So the next thing we want to check is to make sure that Splunk is working, that we can reach it. So on a browser on my host, what I'm going to do is access our Splunk server. So we do that by typing http:// and then the 192.168.0. And that IP address was 145. At port 8000. So we see it's working because we just got the Splunk web page came up, and once again this browser is on our host. However, we pointed to the IP address of that Ubuntu server that's running Docker that has a Splunk container. So to log into Splunk, the username is always admin. If you notice when we set up the Splunk container, we used the same password we did for our server, which was password with a capital P and then the numeral 1, and then we can select sign in. And now, as you can see, Splunk is up and running. So what we have demonstrated so far is we were able to install a Ubuntu server, and then we installed the Docker engine on that Ubuntu server, and then downloaded the Splunk image, and now the Splunk container is working, so we can actually run Splunk and access it from our host. So this is the lab setup. This is all we'll do at this point for this particular virtual machine. Then as we go through each lesson, we may have to add additional services. However, for now, we just wanted to get the server stood up and to get Splunk stood up in a persistent state. And then down the road, as we do other lessons, we'll be installing like OpenVAS, Metasploitable, and other Docker containers to do separate labs. All right, the last thing we should do is we want to power down our virtual machine. And the reason we're doing this is we want to take a snapshot. Now, you could take the snapshot while it's still running. However, I want this snapshot to be in the powered down state. So, and what the snapshot does, it literally just takes a snapshot of the current state of that virtual machine. So the advantage to doing the snapshots, especially on the way we're going to be using this server, where we are going to be continually updating it with new services. If we take a snapshot every time, that way, if we break something, we can revert back to the previous snapshot where everything was working. So in this case, I'll select take, and I'm going to name this snapshot clean with Splunk. And that lets me know that the clean part means that really we haven't installed anything except for Docker and Splunk. So I'm going to go ahead and select OK. So now if we had started this and we were trying to install another service and it breaks everything, what we can always do is revert back to this clean with Splunk, and we don't have to recreate the entire virtual machine and reinstall the Docker engine in the Splunk container. So I'll see you in the next video where we will be installing Windows 11.